Today we're going to talk about constructors and destructors in C++. Now the idea of a constructor method is that when we create an object of a class, then we will need to provide some initial values for that object's variables. And this is a job for a special method called a constructor. A constructor method is really quite easy to define. We simply give it the same name as the class and we make sure it has no return type, not even void. Usually when a method returns nothing, we give it a return type of void, but with constructors we don't do that at all. And in the person class, which is a cut down version on this example, what we've got is a couple of private variables, name and address, both of type string, and we have a constructor method. We know this is a constructor method because it has the same name as the class. So the class name is person, therefore the constructor method name is also person. And it doesn't have a return type, not even void. And as I said a few moments ago, the purpose of a constructor method is to initialize the variables of this object. And so we give the private variable name the value, a default value of 2 question marks, and address 2 question marks. There's nothing special about the 2 question marks. It's just a value I decided to give it as a default. Now we are not limited to declaring only one constructor. We could have more than one constructor. And as long as we've got a different parameter list, that's okay. Both of these are constructor methods because they both have the same name as the class and neither of them has a return type, not even void. This one is known as the default constructor because it has no parameters and therefore it provides a default value for those private variables. On the other hand, this one is what's known as an overloaded constructor because we're repeating the name of the method, but we have a different parameter list. And here we're providing a value for name and for address as parameters. And we're using those parameter values as the values, the initial values of the private variables for the object. We can have as many overloaded constructor methods as we want. We just got to make sure that the parameter list is different. Different in terms of number of parameters, and if we have the same number of parameters then we have to make sure that the types are different. So this gives us then 2 ways of creating objects of the person class. If we were going to create some variables on the stack, then we could do this in 2 ways because we have 2 constructor methods. The first way is simply to declare person P, and because we're not providing any parameters at all, that will automatically call the default constructor. In the second example, person P1 is declared and we're providing in brackets 2 parameters and therefore we're calling the overloaded constructor. If we're going to create objects on the heap, then we would create them slightly differently from when we're creating them on the stack. First of all, you'll notice that we're using the reserved word new, and then we're calling the constructor method. So in both examples we're using new, person, and then either for the default constructor no parameters at all between the open and closed brackets, or we're providing the necessary parameters for the other constructor method. The reason we need 2 constructor methods, or indeed as many as we want, is that it gives the users of the class options. So it might be that in one case the user of the class wants to create an object and only have the default values set up, in which case we would use the default constructor. In another situation we might have some values that we want to use as the initial values for that object, in which case we would use one of the overloaded constructors. So it's just a case of providing options for the users of the class. Now when we're creating variables on the heap, we don't declare them simply as person P, but because these are on the heap, and I'll explain a little bit more in a few moments what this actually means, because we're creating an object on the heap, we need a pointer to that object. And so we preface the variable name P with an asterisk, which says then that P is now a pointer to a person, whereas on the previous slide, P is an actual person object. Let's have a look at how this is different. First of all, let's consider the stack. More properly called, it's the method call stack. And what the stack does is track the methods that are currently executing. So every time a method begins executing, a record of it is put onto the stack. And if one method calls another method, then that second method will also be put onto the stack. And then when a method finishes executing, it is removed from the stack. not only are we recording what methods are being executed, but we also put a place for their local variables on the stack. So let's take a look at an example. We've got the bit of code where the main method begins executing, and therefore the main method is put onto the stack. As we begin executing the method, we come across this declaration of person P. Now, person P is a variable that is local to the main method. It's declared inside the main method, and therefore it is put into that method's area on the stack. And person P then is a person object, and we can see that because we've called the default constructor method, the name and address variables for that object are given the default values. It doesn't matter how many variables we have that are local to the method. Each one of those will be put onto the stack with that method. The heap is something quite different. It's a large storage area that is available to the program. So the heap and the stack exist side by side. Every time a method is called, it's put onto the stack. Every time we create a variable on the heap, that's put into the heap. Let's have a look at an example. Here's the main method beginning its execution, so it's put onto the stack. What we're going to do next is execute this line here. The first thing that will happen is creating the new person object on the heap. Remember, whenever we use new, that will put it onto the heap. And so the object is created on the heap, somewhere in this large storage area in memory. We don't know where, but the runtime environment will work out where to put it. Again, the default constructor method has been called, and therefore the initial values will be determined by the default constructor. The second thing that happens is that the pointer P is declared, and therefore, because that is local to the main method, person pointer P will be stored on the stack. And that is not any longer an object, but a pointer to an object, and its initial value will be null. The third thing that happens on this line is the assignment, which will store the reference to that newly created object on the heap in that pointer on the stack, so that the pointer on the stack is now pointing at the object on the heap. And thereafter, when we want to access that object, we simply access it via the pointer, because the pointer knows where the object is on the heap. I'm just going to go back one slide and take a look at how we reference the methods between the two types of variable. For an object that is on the stack, we can simply call the method by putting the name of the variable, then a dot, and then the method name. Whereas when we are accessing an object on the heap, we don't use the dot notation. Instead, we use this arrow, which is a hyphen followed by a greater than sign. The effect is exactly the same. We're calling this method from the object. It's just that this operator indicates that the method is inside an object that is on the heap. What we're really saying is P is a pointer, we know that, and so we're following the pointer to the object and then calling the method. So when you're using pointers, make sure you use the arrow instead of the dot.